So one more thing before the break. To demonstrate relationship between objects in memory and methods in memory, all executable code likewise is in computer memory. So here's the demo. Eventually what I would like to do is that I want to say rectangle draw, right? I want to have some kind of access to a method that does the draw of the rectangle and also the circle with the draw, right? So I'd like to draw my shapes on my screen. So draw, obviously, why am I hitting V instead of W here? Okay. Oh no, it's just pretty much the font, the appearance of the font that shows as V, but it's really W. Clearly I need to add draw to my shapes. So for instance, rectangle, for the rectangle I can say void draw public, right? Let's make it public so that everybody who has access to the rectangle can do a draw, right? So here it is, draw. Takes no parameters because the object already has everything. And of course, like I told you, because we're going to start using graphical user interfaces a little bit later on after we cover inheritance, for now I will do just simply system out and pretend that it does something. So I'm going to say system out dot print line, and we're going to say on that debugging sort of message, rectangle, right? And we're gonna we should be able to print its coordinates. Of course, I don't have access to the coordinates in base shape because although I am inheriting those coordinates, they're being declared private in base shape, and therefore, if I wanted to print in my rectangle, if I wanted to print X, right, and then if I wanted to print space Y coordinate, unfortunately these coordinates are unavailable. So I have two choices here. One choice would be to go to base shape and add getter and setter to my shape, getter and setter objects, which will set and get X and Y. I could do something like that. Or the second solution to this could be to make X and Y protected. Protected over here, protected, which means this: for anybody outside of this class base shape, X and Y remains private. However, if I extend another class from this base class or superclass base shape, these two become available as if were public, if they were originally declared public. So I can say, all right, then I will stick with this protected solution to my access to X and Y, and of course I can also provide X2 and I can also provide Y2, and this will be my version of drawing the rectangle with just a set of coordinates. So here we go, Y2, right? So this is kind of, you know, simplistic, but it's an interesting thing to try to say draw. In a circle, I can perhaps copy and paste this method and add one to the circle. All right, so here's the draw. Of course, in the circle, there is no X2 and Y2. Instead, I print the radius, right? So I do X, Y, and the radius. And the circle also extends the base class named base shape. Okay, so here's my main method. Right, so now I can call rectangle draw and circle draw. So let's run this just to make sure that everything looks, oh, I of course forgot to change the wording in my method, so I'm just going to go back to the circle and change the word rectangle to circle in my circle draw method. Okay, this is fine. So once again, It says rectangle here and a circle here. And remember, I even managed to, when I went to my main method, before I was drawing them, I created the two objects and I also called move on them. So draw is reasonable to have, but let's go over here and actually show that when we have for instance, rectangle draw. Let me just switch to text here and demonstrate this. If I say rectangle as an example, rectangle draw, I know I have this method in my class, right? And so it has some executable code, right? It has some executable code. I will try, showing it right here, perhaps switching back to a thicker line, right? So this is my rectangle draw. This is another method which I have. You saw me adding it. Oops. So once again, let's switch to a thin line and show this method. Then, of course, these are the two rectangles that I was trying to show you, potentially in memory. And of course, what's going to happen is that those two objects do not get new pointers to the table that finds a method in memory. Instead, the table of methods gets extended here for the rectangle, and there's now another entry in this table which links this with this draw. Let me just finish what I do here, right? And the compiler simply says that if you want to call a move for the rectangle, right? If someone says rectangle move, what compiler does, it uses this reference to the table of methods that belongs to the rectangle, right? It's a separate, this is in separate memory, right? So this is separate memory. This has nothing to do with an object. Object only has X and Y and X and Y and this hidden reference to this table of methods, right? So if I say object move, it goes over here and says, I know that move is in the first slot, and it finds move right here and calls move. If I say rectangle draw, it goes to the same table in memory and knows that the draw method is the second slot in this object and finds my rectangle draw. By the way, when I say hidden member here, in fact, it's not so hidden. Remember, when we work with our objects, internally we have access to something that says this. So this, of course, is a reference to the object in memory, but it does basically what happens in reality, that anytime a method is invoked for an object, it gets this hidden parameter that the move and draw and other methods here will have. I will just do arbitrarily say that when you say this, right? If any time you reference this in your when you reference this in your code, what happens is that if, say, for this object I call method move, right? This here, this returns to my refers to this object in memory, right? If then I call method draw for this rectangle in memory, it goes to the table of methods. It knows, the compiler knows that it's the second entry here, points to the draw method here, and if I decide to use this inside this rectangle draw, then this will be obviously giving me access to this object in memory. So therefore, this is not stored in the object. It basically gets passed as a hidden member to every non-static method of our object. But this is pretty much what's happening with our objects at runtime. So in summary, each instance of our class gets data at a unique set of non-static data attributes. It gets hidden pointer to the table of methods. The table of methods, of course, will contain entry for every method that we use with our classes. Those methods are someplace in memory. The methods themselves are never duplicated with our objects. So therefore, if I added 300 more methods to my class named Rectangle, well, yes, those 300 methods will exist somewhere in computer memory, but the number of methods will not be affecting the size of my object in memory, because I still would be using this single pointer, single reference to the table of the 300 methods that were defined for this particular class. So I know some of this may sound confusing, but I'm just trying to give you some illustrations of all of these things involved before we go to a formal presentation, which will basically go slide by slide and takes us through this conversation the second time. The first time we just do some demonstration very informally, right? I never explain really any syntax. I'm just telling you what I'm trying to envision in memory and what I do in my code, right? So we have those methods named draw. Okay, so let's take a break and resume this conversation after we come back from the break.